What is that, tomorrow? So this is a model of the brain. Not exactly the brain, but models how the brain works. Now, on the left-hand side is the input layer. Those are all the inputs. And on the then you get an output. So if the answer is wrong, the output is wrong, we're going to want to change the inputs, or certainly the way some of the intermediate processes work, right? So our brain changes and it grows. But if we never make a mistake, then we never change the inputs and we never change any of the processes, and we don't grow. So this is just a visual example, maybe a little kinesthetic, if you can see things moving around, of how mistakes actually physically allow us to grow as people. Now, when I was 13, I was in a social studies class in public school. I like my social studies teacher. I hated social studies, but I liked my social studies teacher. And he was working on his Harvard PhD. He's in his 20s, and he said, "No, this is a bright kid. Let me talk to Larry." He said, "You know, I understand you were working on some math thing." I said, "Yeah, I had this idea to create prime numbers, a prime number generator, and I was very proud of it, and I thought it worked, and I was like, wow, this is really cool." And he said, "Yeah, so I'm going to turn on the tape recorder for my project, for my PhD project, and I want you to just talk me through the whole thing and how it works and everything, because And I said, I'd love to do that. So he sits me up in another classroom, and he turns on the tape recorder and has me go to work, and after about 15 minutes, I'm generating prime numbers off my prime generator with a bandit, and then it generated 91. And I thought a second, and I said, it looks like a prime. It's not divisible by 3. I said, uh-oh, that's 13 times 7, isn't it? And I was crushed, because now I went through the math like 14 times, and I thought I must have made a mistake with my generator. No, it was working, and it gave me a non-prime number. So that's when I realized that this is worthless, this thing, and I was horrified. So what would you have done, right? In that situation, well, I hope you wouldn't have done what I did, which is that I rewound the tape recorder and pressed record with nothing to blank out the tape. And I went to my teacher and I said, "I'm so sorry I wasted your time. This thing doesn't work." And he said, "On the contrary," he said, "this has been my most valuable experiment that I've done." I said, "What are you talking about?" I said, "It didn't work." He said, "Well, I'm looking to see how children respond when they find out that they've made a mistake." He said, your reaction was priceless. So there you go. So I just hope you wouldn't have done what I did. But what I realized after significant pain and self-reflection, first that my formula didn't work, that I was way too wrapped up in my ego. That impressing people was more important to me than really being vested in learning new things. I valued being right and avoiding mistakes along the way rather than making them and learning something new. I didn't take the approach of saying, this got pretty close. I found a counterexample, so let me understand why. Maybe that would increase my understanding. Maybe I could fix it and come up with something better. I didn't take that approach. And I'll talk later a little bit about a book by Carol Dweck called Mindset, where she differentiates between a fixed mindset and a growth mindset. And I was exhibiting a fixed mindset. The good news about Carol Dweck's book is she says, even if you have a fixed mindset, you can turn it into a growth mindset. So I struggle with that every day to live up to having a growth mindset and embracing mistakes instead of worrying about making them. So that's when I realized that with my 8th grade teacher, that it was okay. It was a mistake to think that it's not okay to make mistakes. All right, so we all want to be perfect. So what exactly does that mean? Anybody remember the Twilight Zone? There was like seen reruns of that show. So I have a favorite episode from the Twilight Zone. There's this ne'er-do-well gambler, a gangster type, low-level gangster type, wears cheap suits, carries a gun, and does bad things in society. So one day, he tries to rob a bank, but he gets shot and killed in the robbery attempt. So it's like he's in a dream, and he wakes up, and he's in front of this very well-dressed, and he talks to some other guys in the tux, and it's very nice to him, and he's just warm and empathetic with him. And he realizes that he must have died, and this is where he went to. So everything is there. He says, let me show you your new quarters. You know, a beautiful apartment, there's a pool table, he loves to play pool, there's beautiful furniture, and the food, anything he wants he can order, and he's on cloud nine, so to speak. And he's having a great time. This goes on for a week or two, whatever he wants he gets. He makes a request, the butler shows up, says, of course, he would have that for you. And after a couple of weeks, like everything is just so great and perfect, and he's like getting a little bored. And he goes to his butler friend and he says, you know, it would be nice if just, he says, you can arrange anything for me. He says, you know, it'd be nice just once in a while if something would go wrong so I could like try to work on it and fix it. And he said, oh, don't worry about it. You'll get used to it. It's great. So he goes downstairs, he shoots pool, deliberately tries to miss a shot, all 15 balls go in. Anything he tries, everything works. So he calls the butler back. He's miserable now. And he says, you know, this isn't at all. You know, this is terrible. I'm miserable. It's like, I just hate being here now. Everything works. This is just not at all what I envisioned heaven would be like. And the butler bursts out laughing and he says, whatever made you think this was happening? That was the punchline of Twilight Zone. So, love that story. Perfection, what is that? What, are we striving for that? Let's just strive to be better at anything that we do, however we define that according to our principles. So here's mistake number 2. When a mistake is made, how do we respond to that mistake? So the mistake, you know, from a higher level is not responding constructively. That's a little bit like telling you, okay, you want to succeed in the stock market, buy low, sell high. So let's put some, you know, meat on the bone of what that actually means. So let's look at some non-productive ways to respond to mistakes. Let's make some mistakes in responding to mistakes, and then we'll look at what does work. So, honey, what's 5 times 3? Your child answers 16. What do you do? Like what, you all can put yourself, I think, in that situation. Like, child answers the question's fairly obvious, gets it wrong. I won't ask for suggestions. But I have heard things like, we just did this yesterday. You don't remember 5 times 3? Or, no, dear, 5 times 3 is 13. Or, that's not right. Try again. You can nod if you've done any of these things. Or, I think you need to practice your times tables. Would you say something else, or maybe nothing at all, or maybe you just frown, or throw up your hands? Well, first let's go a little meta on the conversation and talk about what we're talking about. That's what I mean by meta, which is that someone, in this case your child, made a mistake, and we're talking about taking time to decide how best to respond. And first, do you think that's a good thing to talk about? Is that worthwhile? I hope so, because that's going to help us if we do that. So, if there's no question about it. I mean, how we respond to mistakes, no matter who makes them, no matter how big or small, is going to make a huge difference in the development of our children's learning habits. And it probably makes a huge difference in our relationships with our spouses and our coworkers. It might even make a difference in the way that you respond to your own mistakes. And you wouldn't probably, been willing to show up here unless you felt that way. So it seems like we would benefit from pressing pause, thinking about different ways to respond. In other words, having a mistake strategy. So I guess you could call this mistake, it's a mistake not to have a mistake strategy. But what, a strategy to accomplish what? What are our goals? This is where I'm going meta. So it may be obvious, but let's play safe, press pause, and look at what our possible goals are. So is it for our children to always get the right answer? No, right? Because we talked about perfection. Is it to show our children that we're smart and they can trust what we say and they should obey us when we say it? Is it for our children to learn even if they make mistakes along the way? All right, well, it may seem unconventional, but none of these is the goal. So let's talk about these one by one to see why. All right, always get the right answer. So when a child answers correctly, she feels good and looks good to other people, her parents in particular, or teachers in the school. Nothing wrong with that. But even IBM's Watson how to make mistakes along the way to become the Jeopardy champion. Always getting the right answer only supports the goal of not making a mistake, and that's not our goal because, as we've seen, if you don't make mistakes, you're never going to grow, you're never going to learn. How about showing that we're smart? So this generally results in math-splaining. Has anyone ever been guilty of math-splaining to their kids? So when I think of a teacher in public school, not Anthony, but when I think of a teacher in public school, and not my social studies teacher, one image that comes to mind is an adult standing over a child and saying, no, let me explain it to you. I love math, and I love showing other people how to do math and how it works. But I had to undergo significant personal change to make sure learning work. If all I did was say, I know this stuff and I'm going to explain the math to you and then explain it, well, that's what every other curriculum does. And it's not nearly as effective as we'd like it to be. So it's what I call math-splaining. Here, let me math-splain it to you. The missing piece in that approach is the discovery process of the child. And that involves making lots of mistakes. When you discover something, you're going to go down, dead ends and hit obstacles and so on. It involves making lots of mistakes. So another thing is, here's an example from the curriculum. So, and I'm going to talk about this a little bit in terms of competency and closure, the two C's. But you have a curriculum, it's got a book, and you have exercises, right, drills. So you can never have the right number of drills in the book, right? Because the child's either going to get it, they're going to want to move on, in which case you have too many drills, or they're really excited about it, they're doing the drills, they're feeling good, they want to do more, and there's not enough. So I love the question, like, do you have enough drills in your curriculum? Because I'm tempted to answer, no one does. So what do you do in the situation where a child is the student's running through all the problems, and they get to the end and there's no more? This is my favorite thing. I tell parents when they call up and say, we want more drills, I said, have the child make them up. And they say, well, I paid for this curriculum, I'd like you to do it. I said, well, okay, but your child, by making up these problems, is going to learn so much. They're going to make mistakes creating the problems. And those are the most invaluable learnings they're going to make. So here's what happens when they try to do that. So they're going to create problems in the same way as the book created them, right? But there might be a little nuance. And they're going to change one little tiny thing. You think it may not make any difference, which is a whole study of mathematics called perturbation theory. And so they make that little mistake, and all of a sudden they can't solve the problem. They're stuck. So now this is great. Like in school, we'd say, oh no, we can't cover that. That's not the topic we're covering about right now. But this is where the real learning happens. So now you have this great opportunity well, why is it different? You made this little change. Isn't that interesting? How cool is that? That this little change you made it a completely different problem. Then why is it different? And they can explore what pattern got broken. Patterns. Everything in math is about patterns. Patterns. So, all right. Let's see. Get back to I made a mistake on my page here. All right, great. All right, so there are three major tools you have at your disposal to encourage this discovery process. And these three tools are Montessori's 3-period lesson. This is, show me, what is? The Socratic Method. Do you think a good tool is the Socratic Method? And this one, I don't think anyone's ever heard of unless you've heard my talk, which is MIT professor George Thomas's PGP method. So in a moment, we're going to take a deep dive into the Socratic Method because it includes built-in strategies for the child to recognize and fix his or her own mistakes. That's another huge thing, is we remove the ability for children to recognize their own mistakes, we're doing them a huge disservice. Anybody talks about, anyway, that's a huge disservice for the child. And a lot of teachers think their job is to point out mistakes, and so a lot of parents think their job is to point out mistakes. The best thing a parent can do is to have a child figure out their mistake. And we're going to see something here shortly about this. All right, so the other topics I'm going to talk about tomorrow at 11:30, because I don't have enough time to cover everything here. But the Montessori stuff I'm going to cover tomorrow, and the PGP method I'll cover tomorrow. So, all right, so in terms of, we're going back to the goals and the things that you say. So is it okay to learn? And we were saying, well, that's not really it, right? Because we're not tolerating mistakes. That's not the attitude, is we're embracing them. So it makes perfect sense to say, okay, I know you really understand this if you do some drills and word problems and you don't make any mistakes. So that's okay, but to draw the next conclusion, which is it makes perfect sense to think that mistakes are bad and that we learn in spite of them, mistakes should be tolerated. That's not what we're saying. That's not the conclusion. The best outcomes come when we celebrate them. I talk about Carol, that's Carol Dweck, right there, in her book Mindset, which is an awesome book. I reread it from time to time when I feel like I'm getting too fixed. Fixed mindset people care more about what other people think than what and what they think they can do about what they actually know and what they actually can do themselves. So when they make a mistake, fixed mindset people often give up, like me when I was 13. And they may even cover it up, like I did when I was 13, pressing record on the tape recorder. I'm still embarrassed to say that I did that. All right, growth mindset people value personal growth over what other people think. When they make a mistake, growth mindset people take the time to find out why they made the mistake. And they're willing, even excited and eager, to share their mistakes to help them figure out why they made them. And that's where values come into play. All right, and really it's about values. Ultimately, everything is about values and principles. Do we value our ego over knowing the truth? And if you ask anybody that, people, will by and large say, oh, of course I value the truth over my ego. If I'm going to be shown something's wrong because it's right, yeah, I'd want to know that. So, but we're only living with integrity if our behavior follows that principle. And that's a core principle of Schiller learning, which is that we value the reality, the truth, over being right. Because if we always just want to be right, then why bother learning the math? Just make up what you want. You're right. It's great. So here's a little quiz. All right, which type of mindset does this person have? Steve, straight A student, wanted to go to law school. He took the LSAT, it's the exam you take to get into law school, and he scored poorly. So he decided after that maybe he should choose another career. Debbie wanted to be a diesel mechanic. She was short and skinny. People told her she needed to be big and strong to work on these large truck engines. But she enrolled in diesel engine training technical college anyway. All right, so who is the fixed mindset person? The first guy, Steve, right? Because he gave up, didn't score well. He's very talented, got straight A's, high school, everything came easy to him. Scored bad on one test, all right, let me do something else. While Debbie, all the odds are against her. She had a passion for what she wanted to do. So she was going to move heaven and earth to bring her passion to life. And I mentioned we have a couple of public school teachers here and a charter school teacher, Sarah from Oregon, Medford, Oregon, if I remember. These teachers have all the power in the world, as you do as parents, to influence how our kids, to instill the ability for kids to have passion. And the kids in your homeschool are very, very lucky because you don't have to deal with the bureaucracy of the public schools that these teachers have to deal with. But if you think about what education ought to be, it's about principles and values, number one, like what's important to you, and to help kids develop the criteria by which they can define them for themselves, because no matter what we do, our kids are going to have their own principles and values. Everybody's got a really different set of principles and values. There might be little changes here and there. And so how do we help people develop, little ones, develop their own principles and values that they can live by? And then the next step is, how do we help them develop the abilities to live with integrity with those principles and values? And to do that, then you might need a little bit of knowledge. So for example, if you value truth, knowledge of a fallacy is critical, right? And the ability to recognize a fallacy is critical. Otherwise you can't get the truth. So we start with the value of seeking truth, the ability to recognize a fallacy, and the knowledge of what a fallacy is. Is it confirming the consequent or denying the antecedent? These are common fallacies you hear every day in the news, by the way, just anywhere. In common conversation with people, they draw conclusions. And if you were to say to them, are you aware that you're denying the antecedent? They look at you like you're from Mars, right? But it's a very which is why partly I enjoy saying that to people on occasion when I hear it, because it also gets people to think. And that's what math does better than anything else that I know. It's people to think about cool things. All right, so that's my passion, right? So really, it's also about self-awareness, because you can't be self-aware and have these conversations. Critical part of the process. I could do a whole talk on that. All right, Professor Joe Bowler is another Stanford University professor, like Harold Dweck. She's working on understanding the role of mistakes in learning. And there's this great video, which I try to play, but I never seem to have internet access, so it doesn't work. So I'm just going to show you this. It takes me back. So at the bottom, I don't know if you can see this, or stop by booth 800 and we'll give you this. Maybe on the sign-up sheet that Antoinette's been passing out, we can, if you're interested, we can send you this as well. So this is a link to this video. It's an awesome video. It's the importance of mistakes, and kind of sums up what I've been talking about. Now, we talked about these three goals. Is it to be right, tolerate mistakes, and so on, to show, to mansplain. None of those is the goal. So what is the goal with all this? Well, on the highest level is for kids to reach their full potential. And we can't reach that goal unless we have a good strategy. And so there are two goals to the strategy that do work. The child recognizing that he or she made a mistake. That's number one, which means if we point it out, we're not really supporting that goal. And the second goal is for the child treating the mistake as an opportunity and learning from it. So we've covered that second part a lot. Easy thing, if you want to jot down the URL, just put down mindsetkit.org. mindsetkit.org. They have a whole bunch of videos. I just picked one of my favorites that fit into the talk. But it's an amazing website, it's all free. So let's look at what does work, and here's where the Socratic Method comes into place. So you're working with your child in her homework, and she says 5 times 7 is 36. So of course 5 times 7 is 35, and she got the wrong answer. So what do you do now? And we've seen a bunch of things that don't work. There's a far, far better way to address the situation than saying wrong. Are you sure? Let me explain. So what is it? All right. So when used regularly, this one homework helper tip will single-handedly remove a lot of stress that you may be experiencing, and it'll add interest, excitement, curiosity to your children's schoolwork. So I can safely say this because the Socratic technique that I'm recommending here, and that's part and parcel of our curriculum, was postulated by an ancient philosopher, of course, and it's used today all over the place. The Harvard Business School with their case study method, that is the Socratic method. And many other higher ed institutions. But it's a kick to see a Harvard Business School class, or to see movies of this, where the students prepare a case study, they read 20, 30 pages, a bunch of numbers and charts and information about a company. They come into class the next day, the professor says, "So Ina, is this a good company?" And Ina says, "Yeah, it's a good company." "So why do you say that?" She says, "Well, it's because," I'm sorry to pick you up. So you were nodding when I said good case study. So because their sales went up 20% a year for the last 5 years. So that's your definition of a good company. So what if I told you that the profits went down 50% a year over the last 5 years, and now they're losing money? Would you still call it a good company? Well, no. So that's another definition. So the professor's just asking questions, and you watch these classes, and they tie the students up in knots just by asking questions. And it's a hard thing to do. Harvard Business School professors make $20,000, $25,000 a day doing consulting. But you learn this, you'll be worth that too. You'll be worth that too, because that's the value of it. They get paid their value. You're going to be paid your value by having kids who are really productive members of society and love their life. That's what we get out of it as parents. And I'll take that any day over 20 grand a day. That's kind of hard to say, but that would do it. Okay, so let's see here. Let's use an example of how this works. So here's an example of how you'd actually use this method in the home. So you ask 5 times 7, the child answers 36. Then you ask the child, and I'll explain why in a second why you ask this, what's 6 times 6? It's the same answer, right? 36 to the wrong answer they just gave. So you say, what's 6 times 6? And they'll think a second, and most often they'll say, 36, wait a minute. Maybe I didn't give you the right answer to that previous question. You gave them an opportunity to discover their own mistake. And then you could say, wow, you discovered your previous error, that's great. The parent never said, no, that's wrong. let me show you that 5 times 7 is not 36, it's 35. Instead, the parent helped the child discover the error by asking questions. And the parent reinforced the value of not judging, right? This non-judgmental discovery process by praising the effort, not the result. Key Montessori thing. We'll talk a lot about that tomorrow with Montessori language. Instead of, oh, I love that artwork, it's beautiful. Montessori parents would say, you know, I see how hard you worked on that. What made you pick that red? You know, that's the type of engagement that a Montessori parent would have with their children. But you must have put a lot of thought into making that color the way you did. Well, what about that shape? So interesting you chose that shape instead of a triangle to represent, you know, a certain thing. So now kids are also hearing, you're not just sloughing off saying, oh, that's a great job, but you're actually involved in what they've created, and there's no greater compliment than to be involved in the work someone else is doing. The technique here is, the key technique is to ask that second question, 6 times 6, we're going to go into this now, is to ask a question for which the right answer was the previous wrong answer. All right, it's a little hard. It's actually, this is not easy. So here's how to actually make this work. So after the child says 5 times 7 is 36, the parent asks, the idea is, okay, child made a mistake. We want to have a process that lets the child recognize their own mistake. So our job then is to come up with a different question to which the answer is now correct. And using that, not because we want them to be right, but because we want them to recognize the fact they made a mistake. Have them recognize it. Now this is hard. So let's do this exercise. All right, pick a partner. Everybody's got to pick a partner. You showed up here today, right? Don't worry about making a mistake, it's okay. Pick a partner, pair up with someone close by. People can make when they're trying to help other people learn and reach their full potential. Now, you know, some people might say, well, it's like a trick, right? It's really, you know, there's nothing wrong with being transparent with your kids and letting them know that your job is to ask good questions. And their job is to think about how to answer them in a thoughtful way. So transparency is another principle that we follow with this approach. We're not trying to trick anybody. And if we get a funny reaction from our kids, we can always say, look, this is exactly this is what I'm doing. I'm being transparent with you. I think it's important. Here's my value. It's like, I want you to grow up and recognize your own mistakes when you make them. If I point them out to you all the time, are you going to learn anything? Socratic method. I'm going to like say the Socratic method is good by using the Socratic method, so it's a little recursive. But so, and then we have kids. I have her yawning now, so it's not for me to move on. All right. So what you're doing too. There's no harm in that. And practice and have them deliberately give you the wrong answer and ask them, did I show you that I gave you the wrong answer? Could you tell by my reaction that you gave the wrong answer? And do it until you get it right. And then reverse roles. There's another trick we do with the curriculum. Instead of us asking the question all the time, flip it around and have your children ask you a question and occasionally give the wrong answer and see what their reaction is. And do they recognize it? Do they use the same technique on you that you've been using on them? We hope they do. They've learned something really, really valuable. What is this cartoon? Is this just funny or is it supposed to be? Okay, it's about questions. You think bananas can fall in love? I love that. So, yeah, we talked about switching it up, reversing roles, and you can do this with your spouse if you guys are game. I've not yet heard of anyone getting divorced by doing this. And the other thing about it, it's a team effort. So kids love the team effort thing. Everybody plays by the same rules. It makes them feel grown up. And I think I've covered this to a reasonable extent. Let's move on. All right, we talked earlier about how different ways that people make mistakes. And I'm going to categorize them broadly into two groups. You can categorize it in a million ways, right? I've just chosen this one thing just to help you think about what mistakes are. So, first, math in particular is really messy. But if you were to show up at any school and look at any textbook, you would think it's so elegant, and it's just perfect. It just appeared out of nowhere as this perfection of these formulas. And nothing could be farther from the truth. If you look at Beethoven's manuscripts before they got published, he like erased stuff through the paper. I mean, he would change his mind all the time, and then other composers. I love Brahms. Brahms was one of my all-time favorite composers. But he had a little bit of a fixed mindset, this guy, because while he had over 130 published works, he destroyed probably another 3/4 of the works. We'll never see it. They'll never saw the light of day because he burned them, because they weren't good enough for his legacy. What a loss. Yeah. So, but it's okay, Brahms. We forgive you for that because you left such great stuff behind. So, math is really messy. People make tons of mistakes creating things like Beethoven did with the symphony. And for me, I'm struggling with figuring out how to introduce more homeschoolers to our curriculum. So it's through social media. It's hard. It's really hard. That's why we have people like James and Antoinette to figure out that hard stuff that I am really clueless about. So, we're trying a new campaign. I'm banging my head against the wall. Either I'm going to break through that wall with enough effort, or the wall's made of brick, and I'm wasting my time. And you're doing a social media campaign, and which is it? It's like kind of important to know because that's your money going out the door. All right, so figuring out which is very important to my business, but it's no different to solving a math problem. So the question that I ask myself constantly is, when things aren't working, is it a dead end, or is it an obstacle? And developing the ability to know which is which is amazing, if you have that ability. So let's get that ability developed from day one. Because if I think it's a dead end, like I'm trying to solve a problem, and I think I'm going up here, my first joint in my thumb, and I think it's a dead end, it's not. I think that's the dead end. I go up here and I stop, it's a dead end. All right, I'm going to look for other solutions. And I'm spinning my wheels, and I'm running all over the place, and I'm trying things. I'm getting a whole bunch of dead ends, and I stop and I think, maybe this wasn't a dead end. Maybe this was an obstacle, and I didn't find the right way to break through. And I try to go around it, or through it, or above it, or tunnel through quantum space-time continuum, whatever it is to get through it. And I finally break through, and I get my answer. So a couple of things about this. First, I've really worked hard. Math is messy. I made a lot of mistakes along the way. Tried a bunch of things that didn't work. Finally got something to work. And because I was cognizant of the fact that things are either dead ends or obstacles, and I got to know which is which when I'm working through it, made my journey at least more informed and less frustrated, because it gave me focus as to what I was working on. The other thing I want to mention about this is that all that thinking and all that trying and all the mistake making, when I finally got to the right answer, because no one math-explained it to me, no one told me what my mistakes were, I had to figure all that out myself. And I worked hard, and I learned a lot doing it. When I finally got to the right answer, I got an endorphin release. That child gets an endorphin release that he or she can't get any other way. There's no substitute for that. So people come up and say, Larry, what do you do? And I said, well, actually, I'm trying to solve the opioid crisis in America. They said, what are you talking about? I said, well, kids don't have the opportunity to get high. And they said, well, what? We all want to get high. We like to live, and the best way to get high is from our own internal endorphin release. It's the best high in the world. And it only comes about, we have to earn that high. We have to work hard. We have to make mistakes. We have to struggle. And we get through all that. We work hard, and we work well and smart. And we make mistakes, and we're proud of it. And we learn from it. And we get to that promised land, and the endorphin release goes off, and we feel good. And it's a very interesting thing that happens with that. Children who experience that begin to value working hard and struggling and working through their mistakes and recognizing their mistakes, because they want that high at the end of the day, the good kind. And kids who aren't given that freedom, kids who don't have parents like you who are going to give them the permission to make mistakes and to learn and grow from them, they're not going to get that endorphin release. But they're going to find another way to get it. They're going to turn to artificial means to get it, and that's not just for kids, it's for adults too. And that's why I say one of our secret missions at Schiller Learning is to solve the opioid crisis. Because we want people to get high naturally. And we think using these techniques will let them do that. Sometimes it's a little bit controversial. I think. Well, you're not supposed to get high. All right, well, it's okay. All right. Anyway, all right. Let's see, moving on here. All right, so there's two types of mistakes, great. Obstacle versus dead end. A Montessori thing. So Montessori says, go from concrete to abstract gracefully and gradually. And the whole way Montessori materials are laid out, which is the way we have it in our curriculum, is set up that way. So, for example, kids who are like 5-year-old, 3 years old, 4 years old, even 8 or 10 years old, or even high school kids, like to sit still for extended periods of time. So when kids first start school, their primary means of expression is kinesthetic. Their bodies are changing, they're growing every day. You're growing, listen, you got to look forward to this next 10 years. Your body's gonna be changing, growing. You're curious, you want to experiment. My body's changing also every day, but not exactly in the way that I would want it to, but we are driven at that age to explore and experiment and discover all these changes are going on in our lives. And so we're told to sit. So we're really kind of 0 for 1 with that. Because, and I'm talking not only concrete to abstract, but multi-sensory approaches to education. Now, for 4 or 5-year-olds, their fine motor skills, the small muscles in the fingers, are not the nerves in the tactile nerves in the skin, although those aren't that finely developed either. But the muscles I'm talking about, we put a pencil in their hand and have them write. Well, those muscles get tired very quickly, and they're rough. They're not well developed yet, so they're not good at it, and it's frustrating. And so we're 0 for 2. So that's why I say always writing in a workbook can be counterproductive. So the best curricula get kids out of the workbook and into the world, experiencing math or whatever it is that they're learning, whatever the subject is, in a way that's developmentally appropriate. That's really all we're talking about here, is have your children learning in a way that's developmentally appropriate. That means according to their senses, and it means starting with something that's concrete and then moving to the abstract. So let me see if I can give an example of that with a practical math example. And for this, all right, I'm not going to call up a volunteer. Is it going to fall or not? Is it going to fall? All right. So I'm going to quote from one of the lessons in lesson book 1 in our curriculum. It's a 100s counting example. And it's one of the ways that we have 5-year-olds doing 4-digit addition. All right, so we start. We ask the child to bring us 2 hundreds from the materials bank. These are square flats that are 10 centimeters by 10 centimeters by 1 centimeter. This is 100 flat. So with Montessori as well as Schiller Math, the materials bank is where all the decimal material is located. Units, tens, hundreds, thousands. So the child brings us the 200s. So we say, I asked for 200s and you brought me 200s. That's a Montessori thing, right? They say, oh, that's great, I got these things. All right, so we would then repeat that for 100. You may bring me 100 from the materials bank. And I'm using the word may a lot, you might have noticed. You may have noticed. So I'm going to talk more about that tomorrow in the Montessori thing. Poor James did a video on the power of may, which got well over 100,000 views. And I'll share some of the comments of that video with you tomorrow. He's smiling, sweetheart. All right, so then we put the material together, and we ask the child, how much do we have now? And the children, typically we'll say 300s or 300 if they've heard the term before. So we've just done 3-digit addition. We've never looked at a number. We've never written a number. Well, we did 3-digit addition. That's concrete, right? That's really concrete. Now we can start moving to the next level. We can use number tiles, which are wider numbers that are abstract, and then number cards, and then number tiles, which are all the same size, and then finally we could just write the numbers. But to write the numbers without having gone through these concrete steps makes it very difficult for kids to learn and remember anything. So if you're in a situation where, as one parent before the talk said, you know, they're not remembering stuff, we just went over it yesterday. So a couple of things about that. First, kids aren't computers. So, you know, it's not like you give a program to a computer, it executes it flawlessly every time. Kids need repetition. Repetition's okay. Second, consider the possibility that maybe it's the materials being presented in too abstract a form. Make it more concrete. Now, with this example, we could use the Socratic Method. So let's tie some of these things together. So say I asked for 200s and the child brought me 2 units. These are unit cubes. So we could ask the question, again, we're not going to say wrong or no or try, didn't we just do this? We're going to say, they bring us 200s, right? Actually, they brought us 2 unit cubes. Now we can say, what's a good question to ask now? See how well you've been paying attention. Anybody have an idea as to what question?
Can you bring me 2 units?
Can you bring me 2 units? That works, because that is the right answer to the wrong answer, the right answer to the question they just gave the wrong answer to. Can you bring me 2 units? And a child's gonna like stop and think and say, well, I just brought you 2 units. Oh, I just brought you 2. Oh, there weren't 2 units. Okay, so that's what's gonna go on. Thank you. And great. All right, don't give any clue, the previous answer was wrong, no body language, voice, no language hints, nothing. This is the part that takes a lot of practice. And so I'm giving you a little bit of practice by covering this again. Okay, great. Now, we're going to talk about the 3-period lesson, which can also be used, would be to say, and I'll just cover it briefly here, oh, this is 100. Can you show me 100? What's this called? And if they're not understanding what hundreds are, we just go back to that. And it removes a lot of stress because we just introduce them like it's for the first time, like they've never seen 100 before. I want to talk a little bit about competency and closure. So, which is a huge, another category of mistake that educators often make. Every curriculum on the planet is targeted towards competency, right? We want you to master this material, and that's great. We're no different. But we introduce a second C that we believe is just as important as the first C, competence. Second C is closure. So you have a classroom, think of a classroom in 45 minutes, you gotta learn this stuff in math. Everybody's coming with a different background, different abilities, different whatever. And so we're presenting this one thing. There's gonna be some kids who get it right away and they're bored the rest of the 45 minutes. Minute number 3, they got it, they're ready to move on. They're not able, they're in class, they can't even like mess around or practice or anything. They're kind of stuck, and so they're feeling a little disrespected, like they can move on and they can't. Then you have the kids who just never get it. They're clueless throughout the whole class. They're asking, if they ask a question and the teacher answers, they still don't get it, they feel sheepish about asking more questions. End of the class, they're just as clueless as when they walked in. So we have 2 negative outcomes already. And then there's a third negative outcome, which is the kid who gets it right away and is enthusiastic and wants to test the edges and explore and say, oh, what about this, what about that? That's the kid in the class who, ooh, teacher, ooh, ooh, ooh. They've got all kinds of questions, and we're at home. And so the teacher doesn't want to be bothered with that because they've got all these other kids they're trying to math-splain. So that kid ends up being frustrated and disrespected too. So we have all these negative outcomes. Maybe 1 out of a class of 20 kids might be the perfect time for them to get the material, absorb it, and get closure. They have no more questions. That kid is asking questions, 45 minutes comes and goes, and they've got to learn something new the next day. They've never had a chance to get the endorphin release from really just, sucking the marrow out of that material. So now we can see the important role that closure plays in terms of negative emotions. Competency is one thing. Start paying attention to what the closure level is of that material. If your child gets something right away, they do one drill, and Mom, I get this, Dad, I'm done. Next lesson, please. Great. Let's put them in charge. And let's even have them become self-aware of what their competence level and what their closure level is. Talk a little bit about, I want to get to mistake 5 in a second, I have like 2 or 3 minutes. Just on the competency and closure thing, there are cases where, the fourth case here, they don't have competency or closure. What we recommend with Schiller math, Schiller learning, is to say, great, you're not getting this, and why don't we just move on and do something else? Let's come back to it tomorrow, and maybe you'll be able to be developmentally ready to work on it then. And kids will have one of two reactions to that. They'll say, yeah, great, I'm not interested in that, no interest, let's put it aside, but they know tomorrow they're gonna have to look at it again. Or they might say, what do you mean I can't, I'm not, whatever it is you said, developmentally ready for this. I can do this. Now, this is the most exciting of all, because they're now gonna choose the struggle. They're gonna choose the pain to get to the endorphin release. And it's the hardest thing for parents, because actually no kid wants to have their parents see them in pain. So they actually would prefer if you weren't around while they struggle through this. So the best thing you can do as a parent is to say, wow, I really admire you choosing to do something hard. Let me know if you need any help, and walk away. That's the hardest thing, because some kids will break down in tears as they're working. What parent's not gonna want to solve their kid's psychic pain? But don't do it if it's in this case, because they're gonna be the better for it, and they're gonna learn, they're gonna get that endorphin release, and they're gonna do it on their own terms. All right, mistake number 5. Another case for not being developmentally appropriate, this one's for little kids. You ever notice how kids can count 2-year-olds? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15. And so, oh yeah, well they missed 13, but it's okay. They really, these kids are not knowing numbers. These kids are memorizing, and they're doing things to please other adults. It's really not good to show off kids who are just doing stuff from, if you're saying they have a great memory, that's one thing. Encourage the memory, no problem. But what's really happening here? So parents often make huge errors in teaching kids the simple numbers 1, 2, 3. So here's how parents typically teach. I don't want to say typically. Some parents teach this way. 1, the child says, oh, this is 1. Great. This thing, this is easy. Math, why does everybody say it's hard? Math is so easy. Great, this is 1, terrific. Then the parent goes, 2, and the kid says, oh, I thought that was 1. I really thought that was 1. They just said 1, now it's 2. Maybe it has 2 different words for it. Maybe it's both 1, maybe, I don't know. I'm a little confused. Then the parent goes, 3. This math stuff is hard. I'll never get this. It's one thing, it's called 3 different things. How am I ever going to learn this? All right, so it may seem funny to you, but the way to avoid this problem is to go 1, 1, because the child's watching what's in motion, not what's in your hand. 1. 3-period lesson. This is 1. Can you show me 1? What's this called? Kids aren't going to have any trouble with that. You move on to 2. 2. 2. Now kids recognize this is 2. So before we get to counting, let's identify what the numbers are. And that's another example. It kind of fits into a lot of things we talked about. Concrete to abstract, right? Start, developmentally appropriate, covers all those different things. And I think we're almost out of time. If we're not out of time, but I'd like to leave time for questions. Do we have any time for questions? Do we have a moment? Do we have any questions? Might be a good point. Let me take some questions. What have I now covered?
To start doing math manipulatives with them.
Good age to start doing math manipulatives. There isn't an age before which it's inappropriate. Math manipulatives it's life. It's really a structured form of life. So kids are curious from day one. We don't even know it. They're born, their brain's growing and learning. And so the more variety we can give them in terms of weight, volume, color, shape, texture, the combination of weight and volume varies. And so for kids to get a sense of that. So if we can have them hold anything or feel pressure. There's 4 types of major neurons. You have the neurons in the fingertips, that's tactile. You have neurons in the major muscle groups, the thighs, the abs, the shoulders. Those are muscle neurons, completely different part of the brain. And of course the eyes and the ears. Tons of other neurons, but those 4 major groups allow us to give a true multi-sensory education. All right, so yes?
My 7-year-old, he does his math and he figures out the answer, and I don't know how he's doing it. I tell him to explain to me, and I just don't understand the concept that he's doing. I'm assuming I always just let him do it that way, and then also introduce my way. Do you have any comments on that?
So what Ina said was she has a 7-year-old who like just figures stuff out without knowing. It's a boy.
Yeah.
Without knowing what he's doing.
No, he does know what he's doing. I don't know what he's doing.
Oh, he does actually know it.
He knows. He's figured out some way, but it's not our standard way. And
Right.
so I'm asking him to explain to me, and he's explaining, but I just don't understand.
Does he explain?
Yeah, I don't understand it.
And you don't get it?
I don't get it.
All right, well, go call us and we'll see if we can talk to him. Explain it for you.
Okay.
Maybe we won't understand it either.
Okay.
We recommend him for a Fields Medal or something.
I think most of it is that he's 7 and he doesn't know how to verbalize it, maybe.
Yeah. So he may not have the abilities at that age to. Yeah, good for you to even consider that possibility. That's nice empathy.
So
That's
promote
awesome.
that, and then also introduce other ways of doing his math. Is that
Well, I mean, if he's getting it, does he have closure, right? Does he have closure on that? Is he interested in exploring other ways to do it? You know, if not, it's okay. You can move on. It's cool.
Well, it's funny. My son is 10.
Is it Madeline?
He still does that.
No.
I'm Nicole.
Nicole.
But he still does that. He doesn't want to show he feels his extra steps.
He shows. I'm sorry.
He doesn't want to show.
He doesn't want to show.
It's extra steps.
Have you asked him
He
why?
just wants to get to the answer.
Have you asked him what's the reason? Well, have him self-reflect on that. There's no right or wrong, without judgment. Like,
Right.
what's the reason to make you feel uncomfortable? Do you feel like it would be wrong to expose your thinking? You know, get into that level 2 type of thinking. Like, become self-aware of what you're doing, how you're thinking, how you're behaving. Get away from the math and go more towards, you know, what's driving your behavior in that type of situation. I do not have a psychology degree. Yes.
Is that normal? When I was in school, I used to do that. I would not. I didn't show a lot of work, and I would be able to solve a specific part of the problem, and then as a benchmark, I would make a note for myself where I was at, and then continue with the problem until I felt overwhelmed up here that I needed to make another notation to solve an equation. And is that normal? I mean.
Well, all right, so we don't, I really want to use the Socratic method on you. I said, my first question would be, what's the reason for your question? Do you care if it's normal or not? What's your goal?
Not really. I just have never really thought about it because, you know, throughout school, they always want you to show your work so you could find out where the teacher could find out where you were making a mistake. But if you're supposed to figure out your own mistakes, ideally, and it really doesn't matter.
See, the Socratic method works wonders, doesn't it? That was great. I love your answer.
And so when you're applying the Socratic method to your children, are they finding their truth? Because everyone's truth could be different.
Well, it depends how you want to define truth. Hate to get into that conversation. But, you know, in terms of there being some things that you can prove, demonstrably
So I'm
prove,
saying,
based on assumptions.
for example, my son's figuring it out a different way than I'm figuring it out.
Well, that's not
So
two different
that's his
truths.
truth.
Those are two different paths to getting to truth, right?
Okay,
And
okay.
certainly there's probably an infinite number of paths.
Okay.
I think there's 637 different proofs of the Pythagorean theorem. So, just like anything. Thank you all very much for coming. Come join us in booth 800 and